Previous session, we saw the Taylor series for natural log of x centered at 1. Now, today we will look at Taylor series for sin x centered at 0. First thing we do is figure out the derivatives. So, 0th derivative of a function is the function itself. So, f naught x is equal to sin x. The derivative of sin x is cos x. The second derivative of sin x or the derivative of cos x is minus sin x. Third derivative of sin x is minus cos x. Or we can say the derivative of the second derivative of f is minus cos x. And if we go further to the fourth derivative, you will notice that it is again sin x. And it starts repeating itself. Okay. Since we are interested in centered at 0, let's figure out the derivatives at 0. So f naught of 0 is sine of 0. Sine of 0 is 0. Cos of 0 is 1. Minus sine 0 is 0. Then minus cos 0 is minus 1. And finally, the fourth derivative, sine 0 is 0. Which means non-zero derivatives are odd powers of x. So now, in general, fn0 is equal to minus 1 to the power of n divided by 2n plus 1 factorial times x to the power of 2n plus 1. Now we know the general formula for Taylor series. So let's apply that. F of x is sin x. Sum as n goes from 0 to infinity of fna. Fna is minus 1 to the power of n by, actually it should be n factorial, but since odd powers are non-zero, whereas even powers are 0, we can write it as 2n plus 1 factorial times x to the power of 2n plus 1. Let's expand this. Sin x is equal to, let's take n as 0. So x to the power of 1. Here what happens? Minus 1 to the power of 0 is 1. 2 times 0 is 0 plus 1, 1. So 1 by 1 is 1. So we are left with only x. Now if we take 1, here it becomes x cubed. Here it becomes 3 factorial. And here minus 1 to the power of 1 is minus 1. So minus x cubed by 3 factorial. And so on. So this is the Taylor series for sin x centered at 0. Now what about the radius of convergence? Straightforward way of thinking of it is that sin x is continuous, yes, and it is infinitely differentiable at 0. So which means radius of convergence is infinity. So interval of convergence is minus infinity to infinity. Now let's look at the Taylor series itself in the graph. So this is the slope or the derivative at 0. As I keep increasing the number of terms, you will notice that it gets closer and closer to converging with sin x. If we really want to prove this, then we can do the ratio test or the root test to confirm the radius of convergence. So that was the Taylor series derivation of sin x. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.